Welcome to the Mad Scientist Lab. Welcome to the Mad Scientist Lab. On today's show, we're going to look at an atomic two-dimensional material called graphene. Graphene is sp2 hybridized carbon-12 atoms in the atomic arrangement of a polycyclic aromatic hexagonal lattice. Graphene can be used for advanced electronics because it takes the transistor down to the atomic level, which theoretically is the end of Moore's law. Graphene is theorized to be the strongest material that we know of currently. Graphene is also an excellent electrical conductor, thermal conductor, and is also magnetically inductive. Its potential uses could be limitless. If you are interested in seeing more about artificial theoretical synthesis of graphene in the laboratory, please subscribe and comment below. Mad Scientist out. Welcome to Stage 1, a theoretical artificial process to synthesize polycyclic aromatic sp2 hybridized carbon-12, also known as graphene. Here is a proposed apparatus. Stage 1 consists of a hopper which contains the reactant amorphous anthracite, which is 98% pure carbon-12, which can be likened to charcoal dust. Carbon-12 is the 15th most abundant element in the Earth's crust and the 4th most abundant element in the cosmos. This is the end of part 1. Welcome to the Mad Scientist Lab. In stage 2, we will be looking at enthalpy of sublimation of carbon-12, which is 9,980 degrees Fahrenheit. This endothermic process breaks the carbon-carbon bonds, which is 2 bonds for every carbon-12 atom liberated. This process also frees up an electron by losing the 2p orbital electron density probability cloud. The carbon-12 atom is now positively charged with an extra proton. It is called a carb-cation. This is the end of stage 2. Mad Scientist out. Welcome to the Mad Scientist Lab. On the show today, we're going to be looking at stage 3 of the graphene machine. In stage 3, the freed electrons are collected to positively charged cathodes. The carb-cations are falling through free space, repelled by each other, and also repelled by the overall positive charge of the cryovac energy chamber. This is the end of stage 3. Mad Scientist out. Welcome to the Mad Scientist Lab. On today's show, we are going to be looking at stage 4 of the graphene machine. In stage 4, the positively charged carb-cations are falling through free space in the cryovac energy chamber. Remember from stage 2 that we lost the electron in the 2p orbital. So now the electronic configuration of the new carbon-12 atom is 1s2, 2s2, 2px1, which accounts for our 5 electrons. Next, we energize the new carbon-12 atom with electromagnetic microwave radiation, and that flips the atom upside down, reversing its spin direction and phenomenologically transmutating its orbital configuration into 3 sp2 hybridized orbitals and 1 2pz2 orbital. This atom now has powerful dangling sigma and pi bonds to form a new allotrope of carbon-12. In this case, it will be polycyclic aromatic hexagonal sp2 hybridized carbon-12. This is the end of stage 4. Mad Scientist out. Welcome to the Mad Scientist Lab. On today's show, we're going to be looking at stage 5 of the graphene machine. In stage 5, the sp2 carb-cations are falling freely through space inside the positively charged cryovac energy chamber. So the atoms repel each other, and also they are repelled by the inside walls of the chamber. The sample tray is fitted with a negatively charged nanonode lattice. The sp2 positively charged carb-cations are attracted to seat themselves over the negatively charged nanonodes. This is the end of stage 5. Mad Scientist out. Welcome to the Mad Scientist Lab. On today's show, we're going to be looking at stage 6 of the graphene machine. In stage 6, the sp2 hybridized carbon-12 carb-cations position themselves over their respective negatively charged nanonodes. Underneath the nanonode lattice is a base of neodymium magnets. The magnetic field line vectors flow up through the negative point charges of the nanonode lattice. Through pyrolytic levitation, the sp2 hybridized carbon-12 carb-cations float and spin up above their respective nanonodes. When the carbon-12 carb-cations are adjacent to each other, they covalently form sigma and pi bonds with one another. The subsequent bonds formations generate an exothermic energy reaction. Remember, stage 2 was the endothermic energy reaction? The monocyclic aromatic hexagonal ring is now formed. It has dangling sigma bonds at its outer perimeter. The graphene sample will now easily slide off the sample tray. An interesting footnote: 3 million graphene layers equals a thickness of 1 millimeter. This is the end of stage 6. Mad scientist out. Welcome to the Mad Scientist Lab. On today's show, we're going to be looking at stage 7 of the graphene machine. In stage 7, a scanning transmission electron holography microscope inside the cryovac energy chamber is now turned on. It is possible now to monitor and do the quality control of the newly synthesized two-dimensional polycyclic aromatic carbon allotrope. Through STEM electron holography, it is possible to measure the magnetic field, the electrostatic field, the strain field, the temperature, the composition, and the image itself, with resolution down to 40 picometers. The electron density orbital clouds will be visible. If you have any questions regarding this theory, please leave it in the comments below or email me at rosscaldwell41@gmail.com. This is the end of stage 7. Mad Scientist out.